Okay, so I am giving a velocity time graph and you have to draw the corresponding acceleration time graph and position time graph. So suppose you are provided the velocity time graph. So VT graph, and graph is like this. Okay, and I'm giving the values. Suppose 10 unit. This is 2 second. This is 4 second. This is 6. This is 8. Okay, seconds, and this is 10 meter per second. So first is you have to find acceleration time graph and displacement time graph. Draw acceleration and displacement time graph. So you will write the topic converting one graph into other. पहला वाला भी हमने उसी पर किया, तो इसको हम लोग लिख सकते हैं यहाँ पर टॉपिक converting one graph into other. Converting one graph into other graph. ठीक है, तो देखिए कैसे किया जाएगा. Okay, so what we have to do is we are going to learn converting one graph into other graph, and we are provided with a graph, VT graph, and we have to draw corresponding AT graph. Draw AT and ST graph. AT means acceleration time graph and ST means displacement time graph. So how do we draw it? So what we will do is we will copy this main thing. Okay. Okay. So just we will change the values. This is A now, and this is time. Okay, so first we will see from 0 to 2 what is the acceleration between 0 to 2. So acceleration, how can you find acceleration from VT graph? So by finding the slope. So we will find the slope first. This will not be there, so this we need to change. So what will be slope for this region? So if we write the slope here, the slope will be what? 10 meter, the change of 10 meter in 2 seconds. So that is 5 meter per second square, and that will be constant because this is straight line. So acceleration is constant, and that acceleration will have value 5 meter per second square. So what we can write is from 0 to 2 it will be 5 meter per second square like this, and then there is a constant velocity from 2 to 4 seconds. Constant velocity means no acceleration. So this time the acceleration will be 0. So this time acceleration will be 0 from 0 to 4 like this, and then third part acceleration we need to write. So third part acceleration, if we write this part acceleration is how much? The slope we need to find. So slope is changing from 10 to 0. So final is 0, initial is 10, divided by in how much time? 4 to 8. So that will be minus 2.5 meter per second square. So that is minus 2.5 means on the lower side we have to take, and but its magnitude will be less than the this magnitude above 1. This is 5 meter per second square, here it is minus 2.5. So it will be minus 2.5 meter per second square. So graph will look like this, acceleration time graph. Okay, similarly we have to draw the displacement time graph. So if we draw a displacement time graph, so what changes we are going to make here is This will become the displacement. So now this is suppose S, and this is time. Okay. So if you look at the displacement initially, see, initially displacement will be 0 because displacement is started from 0 always. So displacement is change of position. So initially displacement will be 0 at t equal to 0. So we will start from t equal to 0 point, s equal to 0 point, and initially the velocity is also 0. So initial slope will be 0, and as we move forward up to 2 seconds, the velocity will become 10 meter per second. So as we move forward, the velocity will keep on increasing. So slowly it will start with 0 slope, and it will keep on increasing, and here the slope will become 10 units, the 10 meter per second square, that is 10 meter per second square. Okay, and then it will continue to be like this. Suppose it is 10 meter per second square, it will continue to be up to 4. This will be a straight line. From here to here it is straight line. Why straight line? Because this part is having constant velocity. This part is having constant velocity. So straight line. And positive constant, that's why straight line is on going towards the positive direction, upper side. After this, the velocity is decreasing. So slope will be decreasing in ST graph. So slope will start decreasing after this point. So slope will start decreasing, and finally at 8th second the slope is 0. Why 0 slope? Because at 8th second you can see the velocity is becoming 0. The velocity is 0 means in ST graph slope is 0. So at this point slope has become 0. So this is the ST graph for the above given VT graph. So you can see the initially slope was 0, then it rose to some value 10 meter per second, and it continued with that for straight line, and then it started decreasing, and at 8 seconds the velocity has become 0 again, or the slope has become 0.